2-in-1. It can dry the filament, or we can use it as a filament storage. Welcome back to my Tech Fun to another filament dryer testing video. This is Sunlu SP2, a split type filament dryer for the drying and storage. And this video is not sponsored by Sunlu. I got these boxes for free, but I'm not paid to create this video. This channel has its own sponsor, and that's the Polymaker. Now a few specifications. The maximum temperature is 70 degrees Celsius. It has 200 watts PTC heater, and it circulates the air inside. It can accept two 1 kilogram spools or one 2 or 3 kilogram spools. The maximum diameter is 250 millimeters and maximum width is 153 millimeters. So this is big enough, maybe not for every 3 kilogram spools, but definitely for the Sunlu 3 kilogram spools, yes. It has integrated desiccant and hygrometer. When I am recording this video, I still don't have information on the website, but I got some pictures and I can see this is some kind of modular system too, so we can place on the top of each other two of these. So probably that's the reason why I got two boxes. Very shortly, why do we need a filament dryer? Well, some filaments are more sensitive to moisture from the air, like PETG nylon, and maybe you saw my example when I placed the PETG in the water and the printing was full of stringing, and I dried it and it was perfectly clean. And very similar examples you can see on the YouTube with the nylon. And there is something new, PET CF, or in this case GF, glass fiber reinforced PET filament. I have this video in the progress about 2020 alloy extrusion corner brackets. I'm testing different materials and even the position of the printing, and I ran into the problem when I started the print with the PET GF filament from the Kiddie. I did this review about this filament maybe 2.5 months ago, and it was stored in some resealable bag with some desiccant inside, and I thought it should be still dry. And I started with these two. They are printed on bevel bags from carbon without any drying, and I hope it's visible on the screen too. Look at this ugly surface. And I thought there is some problem with my X1 carbon, maybe the nozzle or something like that. Then I printed these two on Kiddie Plus 4. The problem is smaller, but it is still there. And the reason for that it is reduced is that inside the filament is a little bit in better shape compared to outer loops. This is a typical look of the Aura extruded material because it is solid inside, and the reason for this is actually the boiling of the micro drops inside the nozzle. They expand and push out more filaments, and this is the result. And I placed the spool into filament dryer in the morning, and at the evening I repeated the printing, and look at this, perfect surfaces. These are still the supports, I will remove them in that video, and just for the comparison, quite shiny surface, and look at this, completely matte and quite ugly and rough. So as you can see, the drying is important even with the PET CF, or in this case GF filaments. And about the testing, I have that sponge drying test, and these results will be comparable with those which I did in earlier videos. Not exactly the same like drying the filament, but at least we can get some picture about the possibility of this dryer. The packaging is good, the dryer is really protected during the shipping. Close, open. But let's see what's inside these boxes. And this was the content of the package. Two boxes are identical, only in this one I got two spools. One is the PLA Meta and the other is Easy PA. And I'm not sure is it included in every shipping or only for me. And in the other box I got this dryer, because the boxes are open from the bottom. And this is the sealing for that opening. So we can use it as a storage, or we have to remove this and we can place it on the dryer. And we can dry the filament. This is the holder if you want to place the spool in the center of this dryer, or maybe hold a bigger spool. Or we can use these smaller rollers with these ball bearings. In this bag they are still inside, but from the other bag they fall out and they were all over the place. So maybe the packaging should be a little bit improved in that case. Because I also got the letter that this is some kind of early product trial stage and they are still waiting for my feedback too. Like with the E2. And this is the hygrometer, shows the relative humidity. Well, with this early product I didn't even got the user manual, so I guess that I have to pour this desiccant into this channel. I'm just guessing because this is what I had to do with the poly dryer, which is very similar system but smaller. Okay, and there we have to replace the battery if necessary. And it uses two batteries, LR44. And this is the position in the box. I'm installing the rollers. I saw a picture where it shows that we can place these two boxes on each other. But there is no ceiling line here, so this means we cannot really use it for the storage in this position. And I'm quite sure that the drying capabilities are quite limited in this case. This is that heater. There is a switch and a plug for the AC cable. And inside there is a PTC heater which will heat up and circulate the air. And compared to those which works as a food dehydrator, which sucks the air from the bottom, heats up the air and blows on the top, this system uses less energy, but it is better only for smaller amount of the moisture. And that system is better for bigger amount of the moisture, like food. Now, I'm not sure in this case where will it let out the moisture which came out from the filament. Well, maybe we can leave a few holes opened. And the front there is a screen, and I think these are touch buttons. So for the storage, we have to close these holes, close the top. There's a nice sealing around, close on the other side, and also close these holes too. If you want to do a drying, we have to remove the bottom sealing, and now it's ready for the drying. It's time to turn it on and to see the screen, and we realize that this cable is almost 2 meters long. The power button. I think it's quieter than previous models. The operating is very simple, like with the previous model. This is the set button, and we can change which part is blinking. For example, degrees Celsius, and we can switch to the Fahrenheit if necessary. Now I can switch the materials and the preset value. Which is weird for PLA set to 70 degrees Celsius. And here I can change the time. That's it. The air circulation is in this direction, and it returns off the fan after approximately 1 minute, not immediately, to prevent the overheating inside. I'm quite sure that this will be fixed in mass production units, but just in case I never dry the PLA on 70 degrees Celsius, maybe I'll place here some reference table just in case. What I'm still missing with this system is some kind of rotating of the spool during the drying. Because imagine we have some 10-hour drying, and every 1 or 2 hours I want to rotate that spool, even manually, but with this system it's a little bit more complicated. Let me show you. So I have to open the top. There is a sealing. I have to rotate it manually, close it, and I'm done maybe in 10 seconds. But with those old versions of these dryers, I can do it in 1 or 2 seconds. This is my test setup. There will be the location of the sponge. And here you can see two sensors. These are DHT22 sensors, and one will measure the input air and the other is the output air temperature. We will see both on my testing. And with these sensors I can measure the temperature and relative humidity too. And just to have less air inside, because I got similar comments before, I place one spool only on the left side. This is Easy PA by Sunlu. Now when I will start the testing, probably these wires will bend a little bit more and the sensor will be closer to the wall, but this is my setup and this is what I can do now. The data will be collected with this Arduino Uno and my laptop, but the current state I can see on this screen too. And you can see the start values, 24 degrees Celsius inside and approximately 40% relative humidity. This is a sponge for cleaning of the soldering tip, and in dry stage it is 0.564 grams. And I'm adding exactly 2 milliliters of water, but I'm measuring the weight. 2.595 grams. And I'm starting the drying on 70 degrees Celsius. After 5 minutes, the temperature inside is 56 degrees Celsius according to their sensor. according to mine 56 and 51, so quite accurate. Of course they are on different location, but this one which measured the hot air is quite accurate. It's time for the half hour measuring. Almost completely dry, 0.599. And so it's time for 1 hour measuring. .534, so it is drier than before the measuring. Probably it had some moisture in it. And yes, it's completely dry. It's turned off and I will leave it 10 more minutes to collect some cooling data. And I'm recording the log data and it's time to analyze it in Excel table. On this graph we can see the temperature in function of time, these are minutes. And we can see the heat up time, approximately in 10 minutes it reached its maximum. And then we can see these waves because it started here turning on and off the heater. Here it was open for 30-minute measuring. And again we can see those waves, and here it was turned off, and this is the cooling temperature. And I think this will be more interesting. Relative humidity in function of time. And dear Sunlu, I hope you will learn something from this, because for example Bamboo Lab already knows the secret with their new AMS2. So this is the heat up time, and when it reached the maximal temperature we can see actually the moisture stuck inside. Here it was open for 30-minute measuring, and actually I let out that moisture. And of course we have less moisture in the sponge, but it still can push out some. And again it was stuck here, and when I opened for 60-minute measuring, again I let out that moisture. And this is that cooling. The increase of the moisture is because the air cools down. Now don't get me wrong, this is still great filament dryer, and usually in the filament we don't have this big amount of the moisture. But I'm thinking, imagine we dry the filament and we finish the drying, and we seal the holes from the bottom and we want to store that filament. But the moisture will be stuck inside, and the only reason why the filament will not absorb back that moisture is that silica gel which will absorb inside of the filament. But it would be much better if we could exhaust that moisture before we seal it. And this is the result of the sponge drying test, and I will add this data to that summary page on my website. And thanks to this plug I was following the power consumption of this dryer. And this 1 hour of drying with a heat up time required 0.12 kilowatt hours. One more thing I want to check. I will start drying of this nylon filament, and after 10 minutes with the thermal camera I want to see how equal is that heating. This is the back side of the dryer, and we can see more heat from this side. And I will analyze the spool in approximately 10 minutes. It's time to analyze the spool. From the bottom I can see that some points pick up that 70 degrees Celsius temperature, but on the top it is almost 20 degrees Celsius colder. Of course this is only after 10 minutes, but I can see difference in temperatures not only on two sides, bottom and the top, but also between the left and right sides too. As you can see, that's why I would feel more comfortable if it could rotate the spool during the drying. And I'm challenging you to figure out some better solution than mine. I put some string around it, maybe just 2 or 3 loops, and every 1 hour I just pull it a little bit so I can rotate it without opening. But I'm quite sure that somebody will figure out some better solution than mine. And it would be good to include some Teflon tubes to connect the dryer with the printer. As a dryer it works nice. I mean 70 degrees Celsius is quite a good temperature. It can dry almost every filament. For the nylon it's a little bit slow, but if you store that nylon properly, then it's fine. Only I'm not too happy with the drying, that the moisture is somehow stuck inside, so definitely 1 or 2 holes you should leave opened. Maybe an optional solution would be adding a valve, and with a small pump we can suck the air and store the filament in the vacuum like we have with the food storage systems. If the sealing is good, this should work. As a storage, for the 1 kilogram spool it's a little bit too big. We have a lot of unused space. For 2 or 3 kilogram spools, this is perfect solution because you cannot even find easily those resealable bags for these bigger spools. Well, this is my experience with these dryers. If you have some other opinion, write me a few lines down in the comment section. Thank you for watching and happy printing.